Hello everyone and welcome back to our OrCAD X keyboard video series, specifically the PCB layout part of our video series. In today's video, what we're going to do is set up the cross-section for our design, meaning that we are going to set up all the layers for our design such that we have a 4-layer stack up, which is what I want to use for this board, and that we also define the layer thicknesses so that we can properly see it in the 3D view. And then also we're going to talk about how to, for example, set up your colors nicely so that it's easy to distinguish, your different layers, maybe DRCs on your board without having to kind of fiddle around with it too much. So this is what our end goal is, where we have a nice set of colors for our layers. And also if I go into the cross section here, you'll notice that there are already we already have a 4-layer stack up with a top layer, a ground plane, a power plane, and a bottom layer. And I've set up the thicknesses for each of those layers. And if we go into the 3D view, then it is nicely rendered and we can see that this is around 1.6 millimeter thick PCB board, which of course is going to have plenty of components on it in hopefully a short while. Alrighty. So let's go ahead and open this board. So this is where we left off previously. So let's first talk about how to set up our cross section. So to set the cross section, getting a little ahead of myself here, go into Tools and select Cross Section. And this will set up this will open up the OrCAD X cross section editor. Now what we can do in here is control all of the different layers in our design and also the materials that are used in our design for the purpose of, for example, allowing Constraint Manager to then measure things such as the impedance of certain traces. If we need to run other simulations, sometimes it might need to also look at values such as the loss tangent, edge factor that we have set up per layer. Of course, the dielectric constant that we set up for our dielectric materials. So this can all be set up in the cross-section editor. But for the purpose of this fairly simple design, we just want to, if we start, let's just remove some of these layers. Generally, when you start a design, you will have just like this. You will have a, let's cancel this. Let me open up this starter board. So if you go into the cross section, you have a 2-layer board. So what we need to do is to add 2 internal layers and also to change the value of the thickness of those layers. So to do that, simply right-click on the top layer and select Add Layer Pair Below. Now the reason we don't use Add Layer Below is if we select Add Layer Pair Below, it will add both a conductor layer and also a dielectric. Right, so anytime we add a layer, we also want to make sure that there's a dielectric sandwich between it and another conductor so that they don't short out together. So if I select Add Layer Pair Below, you'll see that we'll have this dielectric added and also this layer 1 conductor. Now, because we are looking to design a 4-layer board, we want to just select this option one more time. And now we have 4 layers: our top layer, our layer _1, layer _2, and the bottom layer. Now, the next thing we want to do is to set the thickness of each of those layers. And generally what you should do is to look at your manufacturer, or if you have a manufacturer that you're planning on fabricating this board with, look at their suggested stack-ups or common stack-ups, which they support, and just copy those values in, from their website, for example, into your cross-section editor. So I have here on my other screen one of the manufacturers that I like to use, and I see that their top layer copper has a thickness of 0.0175 millimeters. Now, be careful when you're entering in that value. If I were to enter this in here, you'll see that it's 0.175. That is indeed the value, but our design has the units of mils. So This is actually calculating 0.175 mils, which is very, very, very small. To rectify that, you don't actually have to, calculate what the value in mils is. Just type in millimeters at the end of your measurement, and the cross-section editor will automatically translate that value for you. So this ends up being 0.0175 millimeters ends up being 0.688976 mils. Then we can just go ahead and copy in the rest of these values. So for our first dielectric layer, which is a prepreg, this will be 0.1960 millimeters. And then our layer 2 copper will be 0.035 millimeters. Our core is 1.03 millimeters. And then, usually these are symmetric. So our copper layer 2 and our copper layer 3 are going to be the same. And same with our dielectric between the bottom and inner copper layer. So there we go. I've added in all the values. You can also set a tolerance here. This is less so for the tool to use, more so if you automatically generate, for example, a Stackup table in your drawing, then it can automatically add these values for your tolerance. If we look here, our total thickness is 60 mils, which I believe ends up being right around 1.6 millimeters, which is the standard thickness for, like a 2, 4, 8 layer PCB. One other thing is if you look at these layer types, you'll notice that there's Conductor. And for these inner layers, we can also set it to a plane if we need to. Now, for the behavior of how you're doing your routing, this doesn't really change anything. But when you're setting up constraints, you might have different constraints that you want to use for plane layers than you do for Conductor layers. And that's just another way of organizing your constraints by the layer type, rather than having to set up a separate constraint for every single layer in your design. So I'll go ahead and set these as plane. And one other thing I will do is set my layer 2 to ground and layer 3 to power, because we want our layer 2 to be a solid ground plane and our layer 3 to be kind of a split plane where we have different power rails supplying power to the rest of our board. So if this was a high-speed design, we could also scroll to the right here and choose our materials. For example, copper, you can choose the weight of your copper. If you have different dielectric materials, you can choose FR4, 4.1, HDPE, whatever material you want to use. This will also automatically change your values for example, the dielectric constant and loss tangent. And then, you can measure your impedances using those values. But this is a low-speed board. We're not too worried about this, so I will leave it as is. And before we click OK, you can also export your cross-section to reuse at some point in the future. So for example, if you have a 4-layer Stackup that you commonly use, go ahead and export that technology file. That way, anytime you start a new design that's going to be 4 layers, you just re-import that cross-section technology file. All of these values will be automatically entered in for you. All right, click OK. And as I mentioned earlier, one other thing you want to do is also change the colors for your layers, just so it's a little easier to see what's going on in your design. So what I like to do is if you right-click on this corner here, all, we have this option of rainbow up or rainbow down. And what this does is automatically assign some colors to our Conductor layers, so that if we have, for example, a 16-layer PCB, we don't have to worry about finding a unique color for each of those layers, right? That can be pretty annoying to do. So what this will do is choose a unique color for you, and then basically just go through the rainbow colors and give you a nice little starting point for having a unique color for each of your layers. Now for the solder mask, some type of pink or purple is usually fine for me. These can be either slightly different or about the same. For the Silkscreen, I like to go with white because that's what it ends up looking like in the final manufacturer board. And then for the paste mask, again, I like to go with a gray color because that's what it ends up looking like in the manufactured board. And also, if you use a color and don't know exactly what color it's supposed to be in this swatch selector, you also get these little recent color swatches that you can just click on. So this gray ends up being the same as this gray. And then one last thing that I recommend is for all of your DRCs, if you click this top column, we can set a color for all of the DRCs on all the layers, and I like to use the yellow color. So if I were to, for example, place some of my components on my board, now I can see that the top layer is red, and if there's a DRC, we start to see yellow colors. The silkscreen for the text is showing as white, so that's correct. And then any additional colors, for example, your assembly layers, you can also change those. So if I open up my cross-section done board here, let's go into this board. You'll notice that I already set some colors for my top layer being green, bottom layer being red, and then internal internal planes being blue and orange. Pretty much the same thing which I had just done previously. So we're all done with this video. We are ready to start component placement in our design. Again, I will save this and let you guys have access to this file. So if you want to get started with following this video series from this point, it's going to be the OrCAD X keyboard video series 3 cross-section done.brd. So again, thank you guys for watching. I will see you in the next video. If you have any questions, comments, or concerns, please leave a comment below. And yeah, let's get started with some placement in our design. See you in the next video.